Okay, so, the first principle, you're going to probably start with Newton's laws. My advice is just list the ones you think are relevant. You get into the problem, well, you might have an insight. Okay, this other one's relevant, right? In listing Newton's second law, which is almost always relevant, yeah, if you want to find an acceleration, okay, then you would use Newton's second law, right? Most likely. If you want to find a force on a given mass and you know its acceleration, then Newton's second law is relevant. Anytime you think in terms of Newton's second law, ask yourself, can I bypass Newton's second law and use energy? Okay? Because if you're talking about equations of motion, okay, this automatically tends to get you into equations of motion, right? And in a case like this, where you have a variable force, because the further you pull this thing back, the more force you got, right? And those forces are important. It's not a linear force. It's not a constant force, right? Turns out it is linear, so there are things you can do with it. But really, rubber band forces aren't linear, but we're going to kind of assume they are, okay? So you want to be careful that you don't lead yourself into the use of equations of motion when they're not relevant. We've talked quite a bit about that in the last week or so, okay? So, just a little warning, but those are good things. And as it's going to turn out, Newton's third law is also relevant to the force exerted on the rubber band by my fingertip, okay? But you don't really necessarily analyze those forces, because we're probably going to end up using energy here. Still, if you listed something involving accelerations and velocities, by all means, include it, okay?